Alright, next we're going to have Dr. Elisha Siddiqui from Brookhaven National Lab. And no, we are not related.
Okay, so hi everyone. As you can see, I am not a poster child of John Dowling's student. I'm not loud like him, but I'm just so happy to be here, and I'm so happy that our paths crossed, and that I got to work with him. So I just want to explain the purpose of the title, which I called it the Dowling Nest. So maybe a lot of grad students here would remember this story that that John always called his group like it's a nest, and he's like the big eagle, and we are like the little chicks or the little eaglets. And you know, and while we are in grad school, he's kind of helping us, guiding us through the way, teaching us things. But as you grow older, he then and if he sees like we have got too comfortable and we are like not really pushing to graduate, then he would come saying, you know, it's time to graduate. And if anybody complained that no, I'm not ready, he would say that, you know, when the baby eaglets, they grow up, the mama eaglet has to push them out the nest so that they can fly, and they have room for more eaglets to come in, and you repeat. So that's my version of Dowling nest. This is one of the many photos of people, and this photo includes visiting scholars, it includes high school students, summer students, spouses of the grad students, and that just shows you that he was so inclusive, you know. I mean, it was not just about the student, it was about like the family of the students too. And everybody was in there. So let's see if this works. Okay, so I have kind of partitioned my talk into two sections. So in the first one, I'll just talk about inside the nest, or the things that I learned from John. I think we've kind of heard it a lot over the course of these 2 days, but I'm just going to re-emphasize it. And then I will talk about what I'm doing now and how the things that I learned from John as a student, how that kind of translates into my current work experience. So, okay. So my first interaction with John was, I was a few months into the group, and one night I got a text from him saying, it was an email. He sent me an email, which was like a line email, and he's like, Elisha, you know, try this. What if you have a Fox tape and you have a vacuum, and we kind of pass it through a 2-mode squeezer, and then at the end, like, let's look at the average photon number, and we can build a room temperature photon number resolving detector, and that's a PRL. Can somebody do that's a PRL. And I'm like, okay. And it's like sometime like 9:30 at night. I'm like, we'll battle with this tomorrow. And I took that problem up. And you know, John, because of his background with working in the Army, loved these notebooks that every grad student had. These were the red notebooks. And this one-line idea of John led to this for me, and more uncountable pages of calculation. And during the lunch sessions, I would like literally just come to him like, I don't know where I'm going with this. The average photon numbers is not working out. Let's look at what other, you know, quantities we could look at to kind of have this nice relationship where, you know, that particular quantity of interest kind of scales as the Fox state, which is like, you know, the photon number state. So if you have n, does that, so this quantity kind of at the end would scale with like n times something, you know. And so we finally decided that it was going to be coincidence count, and this. And so this was the result where we did this coincidence counting, or like the second order correlation function, and we got these really nice steps. And John was like so happy when he saw these nice steps, and like we got a room temperature photon number resolving detector, and then we went on and we did the variance of that. And just to say, it increased my tolerance to pain very early on in my career. And you just didn't have to cry. It's like I would say, John, if I have to do like a third order, I'm gonna die. And he's like, no, you're not gonna die. But anyways, in the end, this was also around the time when Lior visited, and of course I was not aware of his shenanigans of getting drunk and saying, I want to work for you. But that was my first interaction with Lior. Was like, he just got aggressive and said, no, 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 no. But through all of the shouting and back and forth, he convinced us that this was not single shot, but it was like an average photon number resolving detector, and it did have the potential to do it like in the presence of noise, like you could still tell it with high efficiency. So after this, we continued with our interactions, and thankfully I had Dr. Lee also as my co-supervisor, and he added that stability and that firmness, like whereas John was like do this and do this and do this and do this, and you can't really pin him down. And I would run to Dr. Lee and be like, what do I do with this now? And he was just kind enough to like sit me down. We would work through the problems, and yeah. So I had the hurricane, and I also had like the calm stillness, which was, I think, needed a much needed balance for me. But just want to briefly mention that while he was in Shanghai and he was talking to Professor Lu and all of this, I get texts from him and like, can you do this calculation for me? And he would like write it down, and then, okay, can you now do this? Now I was his meat machine. And it was, but through all of that, he encouraged me, just like Lior mentioned, Ryan mentioned. I mean, he made me believe that what I was doing was right, I was getting somewhere, I was doing something right, and that I had it in me to solve problems, because he quoted Scully's saying that Dr. Lee mentioned yesterday, if it's too hard for us, it's just the right problem. And that's something I still, if it's too hard for others, it's just the right problem for us. And I still use that quote throughout my, my current position. I always use it. The next lesson that I learned from John was fish or cut bait. So when you have these results, right, as grad students, sometimes you're lacking in that confidence. Sometimes you're like, I'm not sure if this is correct, I'm not sure. And then it's time for you to write up the paper, and you're kind of like sitting over it and nothing is moving. And then John would say, there's a time to cut bait, and there is time to fish. If you keep cutting the bait, you're never gonna fish. In other words, he's just saying, you're a fisherman, and if you are just like standing there with your net, you've got this thing in your hand, but you're not gonna cast it into the sea. If you're not gonna like move forward, you're never gonna catch the fish. So he was like trying to teach that to us. And that also, I feel that was a very valuable lesson, because sometimes we can all be procrastinators and we can all have those writing blocks. I don't know what do with this. And from John, I learned that you may not know exactly how the paper will look like, but if you just start writing and not sit on your results, it's good. So I also encountered the red pen of death in my first paper. I learned storyboarding from John. So, he would always say, make the figures first. Choose the figures you want. Write the figure captions. And then from there, go and start writing your paper. So I think that was an important lesson. So instead of like starting from introduction, method, and blah, 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 choose your best figures, write the figure captions, and then put the story together. I also learned about M- and N- when I sent my paper for review. That was my first paper. And I'm like, what on earth is this M-? And he like literally told me the LaTeX code for that. And he was just so obsessed with it. It was always fun to make up titles with John. So like one John mentioned yesterday, the Mordor. Another one was, I remember it, we were in a group meeting. I do not recall whose paper it was. But he just kind of summarized what the paper is about. And he went asking every person in the room to say one word that they think is relevant to this paper. And so he wrote those on the board. If there were like any repeats, he like slashed them out, like synonyms. Okay. And he came up with a title. And I'm like, this is crazy. But when I reflected on it, I was like, he was having fun making up this title, but he was also getting that entire group involved. So even if it was somebody else's paper, you felt connection. So that was like keeping people together, that healthy interaction. And I mean, it was just, and I did this with my high school students just last summer. When we were working on a project. And I said, okay, let's come up with the title for your paper presentation for this program. And we did that. And I think they enjoyed it. So that's something I learned from him. Then the power of supplementary section and future work. So anytime John wants the paper to be like, it needs to meet certain limits, especially if it's a PRL, but you need all these equations, and some of the referees, they ask for it, like, how did you get this? Like, what is this? Or they ask you for extra calculations. You like just shove it in the supplementary. If the referees are still not very happy and they say, well, what about this? And then John will be like, this will be addressed in a future work. And you move on. The grammar lessons from the nuns. So I also went to a Catholic school. So John was like very happy about that because he was very proud of, the nuns teaching him English, teaching him grammar, and like hitting him with the sticks to get the grammar right. And so he kind of, from that, he appreciated the importance of grammar in technical writing, and he wanted all his students to do that. So when I sent my thesis to John for correction, the RPD happened, and there were mostly like grammatical errors, like the thes and the commas, and semicolons, and all of the other stuff. And check your references. So, I mean, I think he was the first person who I realized actually looked at references. If I sent a paper to him to review, or even like my thesis to review, he checked like the spellings, he checked like the format of the references, and this happened to me for my thesis. That's like cramp time for students, like you're about to graduate, and of course you never started writing your thesis in advance, and references are like the least thing you want to think about. You just kind of like shove them in there. And John went through my references, and he wouldn't stop making fun because I didn't check that my big tech was not doing what it was supposed to do. And I was like, that was embarrassing. I wish you wouldn't have mentioned it right in my defense. You didn't get your references right. They're like, but again, it taught me a lesson that everything that you do that's related to your work, it's not just the calculations. It's not just like the technical content, but everything makes your paper or makes your thesis great. It all has to work together in synergy. So check your references. proposal writing. Lior, you stole my slide. Anyways, John, just pretend this is John, and many people will recognize what I'm trying to say here. So he used to joke to the grad students that, I'm just waiting for money to fall from the sky, then suddenly the money for quantum will start falling from the sky and we will all just be running and catching them in buckets, and then I can support you. And he involved the students to write proposals with him, even if it was just 1 paragraph or 2 paragraphs, but it was a learning experience for us. And one thing that I learned, the golden rule, the one who gives the goal makes the rules. And I recently used this in a proposal that I was working on, and we were in this big meeting, and people were kind of, I don't know what this program manager wants. I don't know, does this even make sense? And I just told my colleague, hey, let's just give what they want. Let's just write what is needed, and then you do whatever you want, because that's what John said. Let's just give them what they want, then you just do whatever you want to do. So, then, presentation and speaking skills. I'm still a work in progress, but whatever. And I've got this green apple. Does anybody remember among the students? Yes. Anyone can answer. Okay, I know people remember. So John had these weekly group meetings on Wednesday afternoons, and he would walk in, after his lunch and whatever, his cappuccino, he would walk in with a green apple in his hand. Every group meeting, and a cappuccino. And he would sit on his favorite chair, they had this favorite spot. You cannot take that spot. And he would just be munching on this green apple, and he would just eat it halfway through, and then it's done. So the green apple is important. And then one of the important lessons that I learned from John, kind of not really the hard way. Let's just say it was not a very comfortable. It was not from a very comfortable position that I learned it. But there's this verse that says, "Preach the word, be ready in season and out of season." And when you are John Dowling's student, you better take this to the bank. Be ready in season and out of season. And I have a story. I have a John story. So, like Ryan mentioned yesterday, that John used to take people to these program reviews by ARO or DARPA or whatever. And so me and another colleague, we got to go to this DARPA review meeting. And John's reasoning for taking us was to show the program manager the poor, needy, hungry grad students so that they will look at us and go okay, and not cut the fun. So that's why we were taken to these meetings. And so he was supposed to give this review to this DARPA program, and the talks were an hour long. And John realized that he only prepared for a 30-minute talk. And thankfully his talk was in the afternoon. So after this morning session is over, he comes up to me and said, "Hey, I only prepared for 30 minutes. Why don't you take the rest of 30 minutes? And then the program managers will see this poor, needy, hungry grad student and will have mercy on them." And I'm not ready. And so during that lunch break, I'm on my laptop pulling slides from different conferences or whatever, and made a 30-minute talk. And believe me, he gave his 30-minute talk with all his funny jokes and that famous animation of a train coming, and somebody as fast as this train is coming, somebody is cutting the tracks as fast as well. And so it's very hard to follow up after Dowling. And I gave that talk, and I survived, but I learned, Elisha, be ready to talk about your work, no matter what. And so that's what I learned. And so the group meetings were funny, They were crazy. I don't know what we got done in there, but we did get something done. John had these bag of markers that he would bring. He would send us to the whiteboard uncountable number of times. I can speak for that for myself. Like, I don't know if I ever got to sit down at the group meeting, like, and he was so obsessed with like these colorful markers, but just to tease him, we would always pick the ones that never worked, and then he'd be like, and then he would complain like, you know, I have all these colorful markers. After I bring all those markers, you stood right in with these markers that I cannot see. Can you write with something that's in the visible range? And then, you know, he would send somebody to his office to get his bag of markers, and then you repeat, right? You solve problems on the board, like, okay, do this, do this, do this, or yeah. And Poopy Brown was his favorite. Probably Poopy Brown will show up somewhere in the slide. One thing I really appreciated during these group meetings was you always had like a dry run with him. If you knew you were presenting at a conference, or you know, you were even giving a poster presentation, everyone had to do a dry run. And then of course you were made fun of. You barely get through the second slide, and everything from your font to the color scheme was made fun of. But you know, in it all, through all of that, he was just teaching us to have better presentation skills. So hence, I have all these bright colors, because in honor of John, he loved bright colors. What can I say? I only work here. Yeah, so I just mentioned that we went to the program review meetings. One thing that he taught me, and I think it was very important for me, was the loudest person in the room is not always right. So sometimes we would have these group meetings, and you know, you're presenting something, and everybody's going crazy, somebody's yelling something, and you know, somebody's trying to like get this point across, and then and I'm kind of like, I don't know where I'm squeezing my voice in here, like squeaking, and he would say this, like, the loudest person in the room is not always right. And that made me, that then kind of encouraged me and put that confidence in me that you have, if you know that this is right, or the calculation that you have done is right, like, have confidence in that. No matter how louder the person in front of you is and saying, no, this is wrong, this is wrong. You just hold your ground and do it. And no matter what goes on here, you keep going. So when we used to give presentations at our group meetings, maybe John's attention would be there like for 4 minutes, and then he would start talking something, and then somebody else, and then he's making these jokes suddenly, and then you are like, do I go on, or like, do I wait? It's like, don't worry, no matter what goes on here, you keep going. And just don't, so like, through all the noise, through all the disturbance, you just keep going. So those were like valuable lessons that I just learned from him. So this is a photo from March 6, 2020, which was my graduation, my defense. And with John, and that's Dr. Lee, John, and the other committee members. And that day I wanted to look a little presentable. That's one of the days you want to look good. And I decided to, like, the only pair of heels I have, let's put them on, you know? And he would not let me live in peace that day. He's like, why are you wearing those heels? I still remember that, but, you know, I made it. So this was, and after that, I had before this, we went to Israel with Lior and John and myself, and there again, you know, I was called to the blackboard, and there are these people sitting, I don't know them, and he's like, do this calculation, and I mean, it was just like never stopping. And this picture kind of is, it's like a combination of all of that, the training and the encouragement, and so yeah. So then, this is a poopy bro, outside the nest. So what I'm doing, these are the people I work with, my colleagues. Mei Feng is my supervisor. Sam is my colleague. Leo is now at NVIDIA, and Andre is an experimentalist that we collaborate with. This is like a Google Map version of Brookhaven National Lab, and the dot is where computational science is situated. So ironically, my affiliation is with Computational Science Initiative. I'm probably a physicist working in, but it's fun. And what I'm doing is like carrying on that idea of having diversity in research. I think John really had that. You know, he was very diverse. He was not somebody you could put in a box. He always thought out of the box. He was. So I'm trying to continue doing that. You know, group meetings, writing proposals, and something that's close to my heart is like paying it forward, like just how somebody invested in my life. I want to do that, and trying to be the John Dowling in my own way, and not as loud, but yes, have that same grace that he had. So I'm just going to give like a brief overview of the kind of projects that we are doing at BNL. So one of them is a physics guided, so this is like a more like a low level approach to quantum computing and optimization of quantum gates. Then we also delve into some deep reinforcement learning assisted quantum error correction. And then another one, which is like, this one is quantum enhanced microscope. So, you know, they're trying to do some we are trying to do quantum imaging with entangled X-rays, and diamond is the crystal of choice. And you can probably see the wire, but trust me, it's kind of there. I mean, it's still a work in progress. This is like not the final, you know, there's a lot of algorithm involved, data analysis involved, but I'm excited about this one. You know, we have had some talks about this project, and, you know, John's name always pops up, and it's just like one of those proud moments that, hey, I know this guy. And I'm not sure if he heard of, if he would be like, if he saw this work, he would be like, God, just shoot me, or he would be like, my jaw dropped on the table. I hope it's still that later. Anyway, so this is, I'm just gonna flash these slides. I'm not sure about the time. So this is just a quantum optimal control that we tried on superconducting qubit systems, and we did these experiments on IBM Q machines, but this can be applied to, you know, any quantum computing system. And so this one is more like a theorist, poor man approximation of like modeling the qubits and just keeping the most obvious Hamiltonian functions. And, you know, you take this and you're trying to solve the Lindbladian equation to produce these control pulses that would kind of drive the gate action that we want, like the target gate. And so then we tested out these pulses on IBM Q device, and we compared our performances, like through just measuring the qubits, and also doing interleaved randomized benchmarking, and we found some improvement. Like for this one, I'm just showing an example of square root X gate, and we got like a 63% improvement just through this simple test. The second work is, which was kind of new to me. I mean, coming from quantum optics, like doing this was, again, if it's too hard for others, it's just the right problem for us. So this one is motivated by deep reinforcement learning. You're applying it to a quantum error correction problem, but we are trying to use this policy reuse. So I will give like a 1-minute review of like the problem setup. So we consider this D by D lattice, right? And all of, let me see. Yeah. So we have this, the physical data qubit is like on all these vertices, and the stabilizer operators are represented by those colored plackets. And what the problem that we're trying to solve is the decoding. So if you're given this given syndrome, can you determine a set of corrections that you would apply to this lattice to kind of restore the state to the original, like to what it was before the error occurred? So we consider like two kind of noise. So of course the error that happens on each data qubit, like a bit flip or a polarizing noise. And the other is a stabilizer measurement error. So when you're trying to measure the stabilizer, that in itself has an error. So now instead of like having a single measurement, you kind of have a series of stabilizer measurements. So, and that's kind of a hard problem, when you have like a series of these measurements to kind of, with the aim to restore your state back to the original. So we relax this problem. We say now that our goal is to kind of suppress the error. So instead of saying that you go back to the original state, you're trying to suppress the errors as much as possible. So the decoding as a reinforcement learning problem in fault-tolerant quantum computing is like you continuously suppress errors on the logical qubit by its actions on the physical qubit of a given code. And the continuously while you're trying to continuously suppress errors, you also have to keep in mind that the noise is also changing continuously. So it's not like a single, just one set of noise, but your noise can vary. So, and that's important to keep in mind. So this is again like a brief review of reinforcement learning. It's like is another machine learning technique which for me personally is very intuitive. I feel like because that's how we as humans learn, as we interact with our environment, we develop these experiences, and based on those experiences, are what we do in the future, based on those feedbacks. And so here, an agent, it kind of interacts with an environment, it learns by trial and error, using feedback from its own actions and experiences. And so you're building this experience memory. Then the question arises is that can we use this idea to do like some kind of large-scale quantum control or like a quantum error correction? And so the goal of this is to maximize this total discounted return, and every time you get this tuple, so ST is like the state of the system at some time t, and A represents like the action that the agent chooses. Then R is like as a result of that, what is the reward you get, and then the next state, and T is like a binary variable where you're trying to verify whether you have reached the terminal state or not. How am I doing on time?
Probably you have 3 minutes left.
Okay, okay, I'll make it fast. So that's the episode summary, right? So you define your environment. You start with a set of states and some initial reward, random, then you choose action, and it's just rinse and repeat. But the goal is you want to maximize this discounted cumulative record, and the agent just needs to learn how to choose an action that suppresses these errors. And anytime you do an incorrect action, that leads to the termination of that episode, and you start all over again. So one of the works that showed up by Ryan Siddiqui. I think they developed this really nice environment. It's a really good paper. So we kind of want to do a continual reinforcement learning because we want to take into account that the noise is continuously changing in this error correction code. So we want to employ this policy reuse reinforcement learning. So instead of keep training your agent from scratch for any different noise or error. You build this library of policies, and then for a new noise scenario or this new model, the agent kind of samples from these policies that has already learned from and apply it to this new noise environment. And that one is like computationally less expensive, and the convergence is much better. So this is kind of like a schematic showing what probabilistic policy reuse is. And I'm just going to skip, and I'm just going to show. So, did I get it? Yeah. So we are trying to so we combine this deep Q learning to parameterize, the function by like a neural network, and you construct these cost functions, and then train it like in an online way through like some like an epsilon greedy policy, and so here we try to do it with like a double DQ network. So this is like and because of the nature of the problem, we cast it like in a convolutional setting, but it can be applied to like any neural network structure. And so we got some results. So this is like from scratch for like an error occurring with a probability of say 0.011. And so this is from scratch. And so this was just double DQN. So then you try this for like one policy where the agent was trained for an error of 0.005, but you apply it again to this error system. And then we tried it for like what happens if we have two policies and what happens for three policies. So you see like the difference from scratch to the policy in itself. The convergence is much better, the learning is more uniform, more faster, and the improvement, you can see the improvement. And then when you go from one policy to two policy, it's slightly much better. But there's not much difference between the 2 and 3 policies, and that's something we are trying to think. Like there was this correlation between different number of policies versus like is more always better, or that's an open question. Anyways, paying it forward, training high school students, giving lectures to encourage women in science. I think that was very close to John, who wanted young women scientists like Elisha, especially when the last name is the same as your grad students. He loved the confusion it would create. But yeah, just trying to do that in my own little microscopic way. Invitation, we have a New York Scientific Data Summit 2022 in October. It's in New York City. Come and see us when the abstracts will be open soon, so tell your students about it. The students here, submit your abstracts. We would love to see you there. We have 2 sections just dedicated to quantum. So thank you, and I want to advertise that we have an opening for quantum X-ray bioimaging and astrometry. So those people interested, please contact me. This is the link. I'll just send you the link. So thank you very much.
All right. Any questions? Dr. Elisha? Yes.
Page 16.
Oh, Lord. Page 16.
It looks all the same to me. What's the improvement?
It's the red line is like the guiding line. So you see the blue line is the agent doing its thing. The red line is like is at 100. Like it's like the cube. I don't want to but that's like our the figure of merit. So as you see, like when you use the policy reuse, we are getting closer to the red line. That's like our from scratch
getting closer to.
And these again, like these are I just got it like probably this week. So there's a lot more work to be done. Okay. Yes.
Page 18.
Oh, these people are counting.
Just wanted to take a picture. Thank you.
Any other questions? I had a question.
Sure.
Okay, so you're using reinforcement learning to solve your problem. How do you pick, why did you pick this machine learning model? There's so many out there. Why this one specifically?
So actually, do you mean like policy reviews? Or?
Yeah, like agent running.
Yeah, so the policy reviews, we actually tried it for a different problem, which was quantum architecture search, and there was like a lot of promise in that project. And so the next question was like, can we do quantum control or quantum error correction using this kind of setting? Like you're building a library of policies. You're basically building these experiences. So if the agent, because like, you know, in real systems, the noises are kind of unpredictable. You don't know, and the noise is continuously evolving. So the reinforcement learning with that idea of like adaptability and that experience hopefully can help with, like, can be more robust to noise. So.
Okay, thank you
Thank
so
you.
much.